Hey guys, what's up everybody? Welcome or welcome back again to another tutorial video from the Apex Academy of Mathematics. My name is Akin, otherwise known as Apex LNU, and in this video we're going to be talking about the arithmetic laws in mathematics. Alright, so if you like this video, and this of course is going to give you some value, be sure to hit like on the video, smash that subscribe button below, and of course smash that notification bell for future updates and future tutorial videos. All right, so let's jump right into the video, guys. So there are basically three rather arithmetic laws in mathematics, and of course these laws I've listed them here right below for you: the commutative or commutative law, the associative law, and the distributive law. All right, and these laws were basically developed for the fundamental aspect of math. All right, so let's get into it to find out what these mean and look at some examples of these laws. All right, so let's look at the first one, which is the commutative law. And as I've defined here for you in basic terms here, that the commutative law states that the order in which numbers are multiplied or added does not change the end product or sum. All right, and of course I've placed in red here for you something that you must know, that the commutative law does not govern division or subtraction. All right, so let's put a visual example of what the commutative law is saying on the next page. All right, so the commutative law basically is saying here for us that if I have, say, two numbers which I am multiplying or I am adding, then no matter what, or no matter which way I decide to add or multiply them, I'm going to get the end result to be the same, or the end sum to be the same. All right, so let's say I have, let's start with multiplication here. 2 multiplied by 3, I'm going to get an end product of 6. But if I decide to multiply 3 times 2, my end product will still be 6. All right, fantastic. And if of course I have negative 3 multiplied by 5, I'm going to get negative 15. And if I decide to say, hey, 5 times negative 3, I'm still going to get negative 15 for my answer there. All right, so that explains the multiplication aspect of the commutative law. Let's look at the addition now. So let's say I have 2 plus 5, that's going to give me 7. And if I decide to say, hey, 5 plus 2, I'm still going to get 7 for my answer. All right, so that basically explains for you the commutative law for multiplication and addition. Now in red, I placed a note here for you that it does not govern division or subtraction. So let's look at the division part, right? Be sure to know that 10 divided by 5 is not equal to 5, or I should say 5 here divided by 10. All right, you cannot change the order in division and still get the same result. Of course, we know that this will be a value of 2 and this will be a value of a half, and of course clearly you can see that 2 is not equal to a half. All right, and the same result goes for subtraction here. Negative 2 plus 5 will not give you the same result as negative 5 plus 2. All right, so you cannot switch up the signs and get the same end result. However, if you allow, say for example, this, if you can turn around the sign here, let's say 5 minus 2, you can see that the 5 here was positive and the 5 here is still positive. So I've changed the order, but that is under the concept of addition. But if you were to change the sign, let's say make the 5 negative and the 2 positive, then you would not get the same answer. But if you change the order in terms of how you are adding or subtracting, you will get the same answer. All right, so hopefully you somewhat understand the concept of that explanation there for you. Okay, good. So let's look now at what is called the associative property for mathematics here for you guys. All right, so it says here that the associative law states that the order in which numbers are grouped under addition and multiplication also does not change the end product or sum. All right, so there are cases where you have a long line of numbers to add or multiply, and then it just depends on how you view the question per se, that you want to add or multiply first. You, of course, if it's all multiplication, you can multiply in whatever order. If it's all addition, then you can add in whatever order. Combining the signs, multiplication and addition, of course, multiplication will take first preference over addition. All right, so let's look at an example for the associative law. If I say, for example, have 2 times 4 times 6, I can decide to say, hey, one way of doing this is to say 2 times 4, associate those two numbers, then I will multiply that product right here by 6. Or I can simply say, hey, 2 times and associate the 4 and the 6. Right, so I can find the product of 4 and 6, then multiply the result by 2, and of course I can simply find the product of 2 and 6 and then multiply the result by 4. I'm always going to get an answer of 48 for each of these product here. All right, so the order in which you decide to group numbers that are being multiplied together does not change your result. However, but for addition now, it's the same principle. 3, let's say 3 plus 4 plus, let's say 5. All right, we know that the end result of this here is going to simply be 12. Okay, but if I decided to say, hey, add the 3 and the 4 first, then add the 5. Okay, let me see here. So I'm going to add the 5 last, or I'm going to say, hey, I can add the 4 and the 5 first, then I'm going to add the 3, or I'm going to add the 3 and the 5 first, then I'm going to add the 4. My end result is always going to be 12 for my answer here. All right, wonderful. So hopefully I explained that clear enough for you. All right, so let's look at why it does not govern division and subtraction, or I could say, so let's say here that I have 2, say 2 minus 3, let's say here, now let's look at minus, so 2 minus 3 minus 5. All right, if I say 2 minus and I associate the 3 and the minus 5, it will not give you the same result as if you're going to say, hey, 2 minus 3 and then minus the 5. As you can see here is that this answer will work out to be, let's say 3 minus 5 here is -2, and 2 minus -2 is going to give you 4. So that does not give you the same result here, because this works out to actually be -6, because this is -1 in right here, and -1 minus 5 is actually equal to -6. So you've got to be careful when you are grouping numbers that have straight subtraction or division. All right, and look at the division example here. Like if I have 4 divided by 2, or let's use a bigger number, I should say. So let's say 8 divided by 2 divided by 4. All right, if I associate the 8 divided by 2, I'm going to get simply 4 here. Yes, and if I continue to divide this here by 4, my answer will be 1. However, if I decided to, hey, associate the 2 divided by the 4 here, 2 divided by 4 is a half, and 8 divided by a half is actually going to be 16. So it does not govern the division and subtraction aspect. All right, so basically we're saying here that the commutative law, division and subtraction is non-commutative, and also division and subtraction is non-associative. All right, so be sure that you understand that principle there. Okay, so let's look at the final law now, and that final law, of course, is the distributive law, or sometimes otherwise called the distributive property. All right, and the distributive property states here that multiplication must be done over addition or subtraction. Basically, this governs calculations of numbers in bracket, and this should be in, and this should be numbers, and it should be in, so in brackets. And by extension, it's kind of supporting the PEMDAS principle. Okay, so let's look at a quick example here for you. Let's say like I have a number, and there are numbers inside the bracket here. Let's say 2 open bracket 4 plus 7. All right, this can be worked 2 ways. Of course, we can use the PEMDAS principle here and do what is in the bracket. So that's 4 plus 7 is 11, and of course 2 times 11 is 22, and that is just using the PEMDAS principle. But by extension, the distributive law is saying here that I could simply use the 2 to distribute over the 4 and the 7. So I could say 2 times 4, that's going to give me 8, and of course 2 times 7, that's going to give me 14, and of course 8 plus 14 is 22. All right, so the distributive law basically is most useful when you're doing concepts in algebra. When it comes to numerical calculations, of course, you may or may not have to use it. But say, for example, you have 2, let's see here, 2 open bracket 4x minus 9. Of course, in the bracket here, PEMDAS is non-applicable because these 2 terms are unlike, so we cannot take 9 away from 4x. So we are forced to here use the distributive property, which will give us a expression for our answer. So 2 times 4x is actually 8x, and 2 times 9 is actually going, or 2 times negative 9 is going to give us negative 18. So this basically here is our final answer. All right, good. So that brings us to the explanation behind the distributive property, and of course the final law for arithmetic. All right, so guys, thank you so much for watching this video to the end. And of course, if you've managed to reach to this point and you have actually earned some value from this content explained, be sure to hit the like button below, smash the subscribe button, and don't forget to hit that notification bell for future updates on future tutorials. My name is Akin, otherwise known as Apex Elenio. Thank you, and I'll see you next time in another tutorial video.